we're going to solve this equation by graphing, the first thing we want to do is look at each side of the equation individually. This side gives me y equals negative 2x plus 3. The other side gives me y equals x plus 6. So I'm bringing in the y equals part. I'm not doing any symbolic manipulation on the equation before starting this. I just want to consider each of these independently, draw them on the same grid, and look for that intersection point. So to draw this first line, I can see that I have a slope of negative 2. I'm going to think of that as negative 2 over 1 for the sake of drawing this line. And I also have a y-intercept of 3, meaning I'm going to start at the point 0, 3. So here is my y-intercept, and here is my line. And I'm going to go ahead and label it too. For the equation, it's not that important to label these lines with their equations. For the inequality, it's really necessary to know which is which. So this keeps going on both ends. Now we're going to switch over to the other equation. If we're going with slope and y-intercept, this is a slope of positive 1 over 1. So that means from my y-intercept, I'm going to have a rise of 1 and a run of 1. And I'm going to start from 0, 6, my y-intercept, from the form y equals mx plus b. So here is my y-intercept and my line with slope 1. Let's start from this direction first and then come back and fill it in both directions, trying to go through every little grid intersection in order to have that slope of 1. Okay, pretty good. And this is the line y equals x plus 6. So my intersection point is clearly this point right here. The coordinates of it are negative 1, 5, but my solution to the equation is only the x value. Remember that the meaning of the y coordinate of that intersection point is the value that both sides of the equation would take on in equilibrium. For example, if I were to check my answer by plugging this x value into the equation, I see that I get 5 equals 5. I can also see that 5 is the y coordinate of that point. It is relevant to the equation, but it is not part of my solution. I'm going to take a look at now what we call a compound inequality. This is a compound inequality because it has 2 inequality symbols in it, so it actually has 3 parts total. The inner part, the middle part, we'll go ahead and let y equal 3x plus 2. That's the part that will have the most interesting graph in this case, right? We have a slope of positive 3 over 1. We have a y-intercept of 2, meaning we pass through the point 0, 2. Looking at the other 2 pieces, when I let y equal 2, I can see that that's a horizontal line. And when I let y equal 8, that's also a horizontal line. So we want to draw all 3 of these. Let's go ahead and start with our y equals 3x plus 2. Here is the y-intercept of 2, and a slope of positive 3 over 1 means we need to pass through these points. Every time I go right 1, I go up 3, or if I go left 1, I go down 3. And then I can draw the line that passes through those points. So that is y equals 3x plus 2. And I'll draw the horizontal lines y equals 2 and y equals 8. Now, to look at this compound inequality, I want to step back and look at it as a big picture. When I read this from left to right, I see that 2 is less than 8 and that both of my inequalities are less thans. So it does make sense to interpret this as a between. I'm going to think of this as I want the part of y equals 3x plus 2 that lies between these two horizontal lines. I do need to check the inequality to make sure it makes sense before I just assume that that's my solution set. Another way of thinking of this is to say that y equals 3x plus 2 should be greater than or above y equals 2, and it should be less than or below 8 by reading from the middle in each direction. But I find it simpler to just use between, so that if I now come and highlight the part of this graph that is between the two horizontal lines, I can see it here in this blue. But again, remember, we need to translate this into a set of x values. The y values 2 and 8 really jump right out, but the x values I just trace vertically to the x-axis and just forget about the y's and just look at the x's. It looks like this set really goes from 0 to 2. So let's now use a dark blue here and highlight what the actual set is. I have a strict inequality at this intersection with 2. So that means I want an open circle here. I have an inclusive inequality at this intersection with 8, which means I want a solid or closed circle there. And then I want to indicate that we have everything in between. So this solution set looks like open bracket 0, 2, closed bracket. It also can happen that I'm given an equation or an inequality to solve from a graph, and I am not even given a symbolic form of the equation or inequality at all. This is a way of sort of forcing me to solve it from the graph. In this case, I can see that f of x equals -1, where f is defined by this graph, right? So we're assuming the function f is some linear function that has this as its graph. I would want to think of this side as being y equals f of x. Well, that's just the line that we're already given. And this other side as being y equals -1. Well, y equals -1, again, that's a horizontal line. So I have that line drawn, and I am looking for the intersection. Here's my intersection point. This also is considered an equation in x. F of x is some expression involving x, but to solve this really means still to find for what values of x this equation is satisfied. So again, I'm going to only give my x value and say x is equal to 2. Same idea with the next one. We're going to call this y equals 4. And the left-hand side is still y equals f of x, so it's still the line that we were given. I will go ahead and draw a line at y equals 4 and find that intersection. Again, the x-coordinate of this point is really my solution. So x equals -1 satisfies this equation. Going on to the very last example, we have a less than Again, I always want to interpret these as either the word above or the word below. Less than suggests below. So I want to highlight the portion of the graph of y equals f of x that is below the line y equals 4. I will go ahead and highlight that in purple. Since there's an arrow on my graph, I also want an arrow on this portion that I'm highlighting. I'm going to make that just a little bit thicker here so that it stands out more. And I can see now, tracing over to the x-axis, this still starts at -1, just like the solution to my equation. I'm going to have an open circle here because of the strict inequality, and I can see that from here my graph really goes to the right. So my solution set is going to be starting at -1 and going infinitely far to the right, therefore going up to positive infinity.